Okay, FabAcademy 2016, week 15, application interface design. Okay, so this is one of the most intense classes in my opinion. Like Neil is covering all programming languages in an hour and a half, which is a lot. It's like, I think there's very few people that can talk like this without being pretentious. But Neil actually knows all those languages, so he can. And yeah, don't be afraid. Like you don't have to go into all of them, but it is a really good idea to try more than one of them. But let's maybe start with some general stuff. So first information that I freshly got out of Neil is the final date where you have to, where the repository gets frozen, which is like your last possibility to upload all your stuff for proving that you did all the assignments. You have to present your final project before, though. It's not, you can't, you have to present your final project. That's one of the check marks. And so presentation is, like I would recommend that you focus on your final project. And once you have this done, you can try to catch up with assignments if you're still missing, because you still have another 3 weeks after the presentations, I guess, until you really have to have everything ready. Huh? July the 8th. That's yeah, July. Yeah. Huh? Yeah. Yeah. Last year we it wasn't so sure. I guess it's July the 8th, 12 o'clock Boston time, which is 4 o'clock in. I know it's probably 3 o'clock here. I know this better than I ever wanted to know, because students like it's always the last minute, and in the end, last year it was always me pushing the stuff, because we had an internal Mercurial server, so you would push to the internal one, and I would have to push to the other one. So I sat there more than once at 4 o'clock at night. Yeah, like the last minute of July the 8th. Something went blip, but I don't know what. If somebody's trying to reach me, please speak up. I don't know where it's blipping. Yeah. Ah, Andy?
Ja, hallo?
Ah, okay. Alles gut?
Alles super.
Okay. So, yes, this is one thing. Another thing is, if you finished your molding and casting, please put your blocks of wax somewhere where I can know that I can remelt them. It's a pity. I guess I will keep them till next year, but just for getting them out of the way, because we're accumulating too much stuff, and it would be nicer to have more working space, no? Also, if your final project is something that needs a lot of space, I will try to get a table for you where you can leave your stuff, so you don't have to break down everything and put it up on the next day. It's not going to be easy, especially since we're going to have all the YAC students going crazy outside. I'm trying hard to conquer the auditorium, which is 100 square meters that we're not using, apart from like 1 or 2 presentations per week. And we need the space, and we need some more tables to work on. But yeah, believe me, I'm trying hard to make this as easy as possible. But in the meanwhile, we have to organize ourselves and keep our space more or less organized. If everybody has their bag and their 5 Arduinos and their handbook and their computer and their lunch and everything on the table, we simply don't have enough space for that. Also chairs, if everybody wants a chair for putting their bag, we would need another 20 chairs, which we don't have. yeah, we agreed on that you decide if it's getting too messy for you or not. Like I would throw all the bags out. There's no need to have you like. Now I'm starting to leave my bag here, just out of laziness. But if you want to rethink this, let me know. Like I think it's gonna get too full here if we have all the stuff lying around. But it's your choice. If you want to live in a mess, go ahead. Then yeah, same thing for the molds for the composites. Once you have your composite finished, give me your mold and I will tidy it up so we have more space here. Yeah, I solved I found out what was wrong with the. Remember that the milling machine many times was scratching over the surface. This has to do with the G0 setting. Let's see if this works. Send an email with a screenshot, but I guess you already saw that. So here, this Z home, this should be something bigger than 0. I guess 1 would be enough, but if you want to, I think the default setting is 60 millimeters. So yeah, just don't put 0. You put everything 0 apart from this one, because in the end it drives home, and if home is on 0, it just drives straight to 0, which is causing all of that.
Are you sure? Because what I actually told it about like on the first couple of weeks, I noticed that like for my boards, I mean I don't know that about the rest, but the boards I did, it did this to the 0 when I accidentally clicked the move to XY home and stop. Or move to XY 0 job, or like one of those.
Yeah, I haven't confirmed it yet, but I studied the code. So if you're interested, so this is my conversation with the instructors. So where is it? Yeah? Ah, no, maybe it's here. Okay, so this was the problem I was describing with the screenshot of our little mistake here. And so there's a line, this is still the code for the last cutting move. And so this machine uses a language that is not G-code, it's called RML. It works just like G-code, only the syntax is a bit different. And it has moves PU and PD. So PU means pen up. And you define 2 positions for pen up and pen down. And so it moves pen up to this position, or it was milling at this position, then it moves the pen up. Then it puts 2 commands for absolute coordinates, which I don't know why they put them there. And then it resets the pen up and pen down position to 0, because this is the value that we gave it for the home. So if you put the 0, it sets the upper height to 0. And then it does a pen up to 0, 0. But since pen up is 0, it goes all the way through. And as soon as I put a value into the Z home, it puts here PU and then 0, comma, and then the other value. Which, from my perspective, now solves the problem. Haven't tried it yet, but I'm pretty sure that this is the thing. If you're interested, I have the RML command guide command reference. This is like the specification of the G code for the modellers. Yeah, to be honest, I would prefer to use regular G code because those machines can also read normal G code. I made a test with the normal G code also does some weird stuff. So yeah, I don't know. I would just prefer to use normal G code instead of this. But yeah, let's see. Okay, so Fab modules is solved. And so let's have a quick look at the schedule and see if I can add anything that Neil hasn't said.
The extension RL is specific for Roland, for Modella?
The RML? Yes.
it's property of
Yeah.
it's the G code for
Yeah.
values.
Mhm.
Can I ask a question?
Yeah.
Like, can you explain how that all language developed? Because that is just for a language. But then what is on the other side?
Okay. So the aim of this lecture is to talk to your boards. That sounds stupid, but that's what we're up to. So since we have all kinds of sensors, we could take the sensor data and visualize it nicely on the computer. Or we could make a machine that we control from the computer. Let's say you make a milling machine and you want to send it commands. You would also have to communicate by serial. This is what all our machines do. And send the commands to your board that then interprets this information and does something with it. Yeah. So the aim is to communicate with the boards you made, which could be either data visualization of the sensors that you have made in the input devices, or you could send commands from the computer to your board. All the different things. Hello? Okay. Does this explain a little bit? Yeah, and luckily most programming languages support a serial interface. So you can directly, from your programming language, send bits and bytes to your board or receive bits and bytes from your board. And yeah, as Neil said, you could do this in C, which is probably a nice exercise. If you don't use any additional libraries, it's just a command line interface, just like the black box, you know, with the cursor, which would be an interesting thing to try because you already have the compiler installed. And if you're interested in this, let me know. I never tried, but it would be interesting. And then he gets into all the other programming languages like .NET and C# and Java, and I guess we just, like if you're interested, ask me on any of them, but the ones I'm going to talk about a bit more in detail is Firefly, which is a plugin for Grasshopper, Processing, which is a standalone programming environment that uses Java for making graphics. It's super cool. It's like everybody's favorite. I don't know anybody that doesn't like processing, except if they're super cool and do like really hardcore stuff, then they need something faster. It's an interpreted language, so it doesn't run as fast as a C++ program, but it's very easy to use. And the syntax that you're using is not exactly Java, but it's very similar. And if you wanted, you could also use a programming environment like Eclipse, for programming Java, and import processing as a library. So, for example, all the MIT guys I know so far, they use this a lot. They just use processing as a library, but program it in a real Java programming environment, which gives you the benefits from both. No. It's two different things. Yeah, they used to have the same extension, PDE. Now they changed it to Eno for the Arduinos, but has zero to do with each other. It looks very similar because processing is based on Arduino, but they only share a similar interface. And both of them have a loop and a setup, but that's about all that they have in common. But they work very nicely together. But I'll get into more detail on this. Then 3JS, this is a nice example. Mr. Doop is the guy that invented this when HTML5 came out. Yeah. This is an amazing guy. Like, it's crazy. He managed to, just by programming something up in his free time, he managed to dominate the 3D world of the internet. Because everybody's using 3JS. We're doing almost anything that is 3D on HTML5. Yeah, have a look at some examples. I would really like let's say you want to, for the code bits in Lisbon 2 years ago, I wanted to make, like everybody, it's a programmer's contest and everybody makes the little avatar head. It's a little robot. And they look quite funny. So this is the original one, but then you can customize it to like have a hat or to have like other crazy things. Well, now yeah. So everybody, for participating, you have to customize your little robot. And my idea was to make one where you can generate a 3D model from the customizations and have a database with STL models in the background so that you can just print everybody's little avatar. So this is something that's possible to do in 3JS. You need a graphics card that is good though. Like if you have an old computer, HTML5 doesn't, or the canvas element won't work on your computer. But I think most of us have computers that are new enough. And yeah, this would be just like an idea. Then yeah, HTML5 in general, like if you look at the examples from Neil in, let's say, the input devices, he puts a little script of JavaScript that can also communicate with your boards if you install Node.js. So normally JavaScript only runs in your browser in a so-called sandbox, and it's not allowed to leave this area. It's not allowed to read or write files on your hard disk. But Node.js is kind of the missing link, which you put like in between your website and your real computer. And Node.js is allowed to address hardware, and JavaScript is allowed to talk to Node.js. So this is the way you connect the two, and suddenly you can run your machines from an HTML page. And if you look here in the examples, in some of them, there is an HTML version of this. So this is the magnetic sensor. And if you have all of this installed, you can just visualize your data on your screen right here, right now. And if you know how to do it, you could also visualize this on any other computer that connects to the Node.js server. So this is very interesting. This is the way we run, or we are supposed to run the Fab modules right now. But since it's quite complicated, I decided that we continue the way we do it so far. Maybe you remember that in the beginning I had a Raspberry Pi connected to the machine, and then on the other one, I was cursing a lot, but then it finally worked. And then I tried it again, and it didn't work. And yeah, I wanted to save you the complications of this, but this is the way we are supposed to run the Fab modules with HTML5 and the Node.js. Then, yeah, then there's a lot of things that that he just mentions, like all of those. I know most of them. So if you have never heard of any of them, just click on it, read a little bit. It's good to know. Maybe someday you come into a situation where you would need something like this, and like this you already heard of it. I don't know if I should go deeper into this. Yeah. Python and Perl is two different things. Like if you ask a hacker nowadays how they do network sniffing, they would say, oh, luckily we have Python, but we would have to use Perl. Perl is used for its infamous one-line syntax. In Perl you can do almost anything in one line. Very cryptic. Yeah, I could show you if you want. It's great for doing stuff like searching in text, replacing. Like it's a very powerful language. It used to run as a CGI module for websites. So you have a little folder where you put a Perl script into your web server, and you can run it as a program if you have the right permissions. But it's slowly being replaced by JavaScript. And But Java, not really. Java is kind of like own language. Huh? Angular? That's the new Adobe thing, no? Yeah. Okay, and Ruby, I think is Ruby its own language, no? Yeah. Ruby is a language which I think is mostly used for like database stuff. It's also web scripting. Ruby on Rails is like a big, like, what do you say, Schlagwort. Yeah? Okay. Yeah, to be honest, I don't know much about Ruby. But what I know is that you have to, actually, if you want to use stuff like JQ for making websites, you need Ruby. And in the end, it's just a command that you execute for installing Ruby in the command line. And then you can use frameworks that are using Ruby. So it's a bit like Python. It has its own modules, its own, how do you say, repository of modules. Yeah. Maybe just for making a quick one. So Java, not to be mixed up with JavaScript. Java and JavaScript are as different as processing and Arduino. They have a common thing in the name, but they have nothing to do with each other. Java is nice because it can run cross-platform, so you can take the same code and run it on all the different operating systems. And you can do Java applets, which is like a little application that runs in your browser, but it's all kind of old school. It's still good to know because many times you find like interesting Java applets on the internet that somebody wrote like 10 years ago. Yeah. So if you look for an animation of PID control, probably it's a good idea to search for PID Java applet, and you will find it. Yeah, and the OpenJDK is the Java development kit, which you can just download and use for free. Ice-T, I'm not sure. Scala, no idea either. Android, I guess everybody knows. Haskell sounds very old school to me. It's one of those languages that only Neil uses. And then we get to processing, which I'm not sure if I should do a little processing intro right now or tomorrow. I don't know. Should I spend more time on talking about the big picture, or should we go straight into hands-on? And big picture, hands up? Or, I don't know. And processing right away? Okay. Yeah, tomorrow at 3 we do a processing thing. Okay, so wiring is kind of a bit like, it's like, what was wiring again? Ah, it sounds a lot like Arduino. Yeah, but wiring is another, like, it looks very similar to the whole Arduino processing style.
Because before wiring was before Arduino.
Ah, okay. Ah, yeah, this is where the Arduino forward the interface and then all the others. Okay. 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 Yeah. Yeah. Then LabVIEW is the industry standard for visualizing and controlling stuff. It's you have to imagine it in a lab where they have like expensive stuff, and much of the expensive stuff has their own modules for LabVIEW. It's very easy. Let's say you have, for example, my thesis for mechanical engineering was using a 486 processor as a module, very tiny. It goes on a board that sticks in your computer. So I had to program this one in C, and I used a PID controller for making active amortization of vibration in tooling machines. And the way I would interface all of this would be with LabVIEW. So I can easily set up a scope where I see where my data coming from the microprocessor go into, and I can see a nice graph. I can have make my own interface with buttons and sliders and things, knobs I can turn, knobs I can flip, lists I can select from. It's all very easy. You switch from using to editing, and you just draw a new slider, you connect it with little cables that you wanted to control. Then you switch back into editing mode, and you may have a super easy way to make a custom user interface for almost anything. But it's quite expensive if you buy it. And if you're like a student and you're working in an academic environment, I'm sure you know Labview already. If you don't, then probably it's not what you want. Yeah, okay. Yeah.
Like, do you know that there's not really sequence?
Yeah. Yeah. So it's no programming, it's just connecting wires. It's like Grasshopper for graphical interfaces. Sorry. Let's say I explain all the ones where I know. So wiring was not the one. Then Simulink. Simulink is kind of a plugin to Meta. But in the end, it's the industry standard for doing control. It's a big word. It's very powerful. Unfortunately, not open source. But every car, for example, for cars, they mostly program the microcontrollers in the cars using Simulink. So it can interface with your hardware. It has lots of mathematical models that are pre-built. So for example, if you have a DC motor, and you know, okay, if I give it this current and this voltage, it will turn this and that fast. In reality, it depends on a lot more. It depends on the outside temperature, on the static friction that you have on your bearings, on you can easily make many PhD theses out of how to model a DC motor in Simulink. But luckily, people did this before, so now we can just use the model. So Simulink is great, but it's expensive software. Then we have MaxMSP. MaxMSP is a visual programming language for doing multimedia stuff, which includes audio and video and sensors and actuators and all of this. There's amazing projects done in MaxMSP. It's a commercial software, but luckily the same inventor that invented MaxMSP also made an open source version of the same code. It's called Pure Data, or PD. If you want to download it, get the PD extended. And it can basically do the same things that MaxMSP can, but it's less polished and less beautiful. That's the only difference. I like Pure Data a lot. It's really down to the basics, and you can do almost anything. In Galicia, I was working in wave energy generation, and I had data from a wave void, so you see how the waves go through the day. And I can just type the data stream as an audio file. You can listen to the waves as a sound, which is kind of interesting, and normally you wouldn't do this. It's funny that you can hear the tide going up and down. This is something that I wouldn't have realized looking at the data. But once I realized, where does this deep humming sound come from, I realized there's a tide, that the buoy goes up and down, but along the tide. I also did my interface application then with Pure Data. And it's completely wrong. Now I know why. When I had a lab, I think I showed you the one that okay, this is Pure Data. Pure Data can also work with video. It's a library called Gem. And then you can also integrate video, or you can do video processing and all kinds of fancy stuff. Then we have Scratch, and there's Scratch. You have to differ between Scratch and Scratch for Arduino. I think if he's just saying Scratch, I think he means Scratch that is mostly used for programming little games. And it's a funny language that looks like, so for a for statement would look like this. So you say repeat. And then all the little, you pick from blocks and you just drag it in there. And this is very easy to program stuff in video games. But there's also Scratch for Arduino, so you could program your Arduino the same way. There's also a version of OpenSCAD in Scratch style. So you can also make a 3D object using the same graphical language. Should definitely have a look at least one of those. And yeah, like it's all quite limited. But, you do get quite far just with those simple things.
I will bring some Raspberry Pi laptops on the weekends for the kids workshop, and I know if somebody's interested, I can show them some Scratch Minecraft hacking.
Yeah, cool. Yeah, so Scratch, I think, is installed on the Raspbian by default, right?
Yeah, it's installed on every Raspberry Pi distribution.
Oh, it's too high.
Yes, it is.
Okay, sorry. Yeah, thanks, Andy. App Inventor, I think this is another MIT project. And I think you just should have a look yourself. I think it's an easy way of making apps. I'm not entirely sure. I've never tried it.
Did you read about P5? Is the Java version for processing?
Yeah. I will, yeah. P5 is a library for processing to make buttons and sliders. We can talk about this tomorrow in the processing part, no? But the control P5?
Now they see the P5.
Oops, no, this was the wrong page.
Remember that they were waiting to run processing technique.
Yeah.
So now they do
Done?
done.
Oh, okay.
Basically, it is a new processing run in the dot.
Okay. Yeah. Yeah. Woohoo! Flying teapots. Yeah. Oh, but it doesn't move. I thought it's moving with my mouse. Oh, no, there it is. Okay. Yeah. Yeah, more on processing tomorrow. Then, where are we? Here. Okay, Bash is the born again shell. And this is what we're using when we're talking about the terminal. And the terminal is basically another programming language where you can do complicated stuff, and you can read and write to the serial port. So this is, if you want, you could make your application in Bash. But yeah, I don't know. You would learn a lot, definitely, if you do this. That's easy. I can show you. Yeah. Yeah, this is. I still have this on the final project recommendations, and I put ASCII art, which would be something that like there's a lot of potential in now that we not only have ASCII but also Unicode. ASCII is like the 128 letters that you can do with our keyboard, but now most computers understand Unicode as well, which is like a few more, a lot more. And actually, you can have animated little, like all the emoticons that you put into Skype. You can have them as a Unicode character, and you can you can actually use those for as text, even though they're images. So I hope you don't get offended, but if I show you my FabAcademy folder from last year, oh no, where is it? Okay, so this one is not. This one you could probably do it with ASCII, but I think I had another one. Or was it in there? No. Yeah, never mind. But you can have like a bicycle as a letter, and this would appear in Skype, it would appear in whatever messenger you use, and it should be fun to do some project with it. Because there's huge libraries. There's open source libraries for icons. Like in the beginning, I thought it's a bit stupid, but actually, we use icons a lot, and they're very helpful. Oh, this one is far too high. Eh?
So high.
Oh, I'm turning in the wrong direction. Yeah, maybe you should restart it. Am I turning in the wrong direction or what?
Yeah, it turned in the other direction.
You want to give this a try? Okay, so TCL, what was TCL again?
Actually,
Yeah.
there's no
There's no glass. Oh, this is okay. Then Python, and this is something where it gets interesting again. Everybody loves Python. You hear Neil, and Python is so great. And actually, even though they did this crazy Python 3 thing that messed up everything, people still love Python. And there's lots of libraries for Python, like the one that you installed, the tkinter. And tkinter is actually a nice library. And maybe if we search for images, yeah. So you see, this is all tkinter, and this is all the types of interfaces you could make. You could make an interface with sliders that previews your, generates some output and shows you a color. You can make little games. You can have all kinds of graphical interfaces. Searching for tkinter and widgets, like this is what they call widgets, like those little elements like sliders and lists and stuff. They are very accessible, and just looking at the examples from Neil, you already use them, and it's really super easy. You just say, I want a slider, and the value should be this one, and it gives you a nice windows. Looks all like a normal user interface, and it runs cross-platform, so you can run it on Windows, Linux, and Mac. And yeah, that's the beauty about.
They use it for example, but what
you can do almost anything with this. For example, one of my students that you probably already know, Bruno Mauricio. Yeah. So Bruno was getting into the APA, and so he created this application. So for his final project, he made this power plug that communicates over the network, so you can remotely or from the internet turn on and off lights or motors or whatever, or monitor the temperatures. And so this is a cross-section of a house. And if you hover your mouse over it, let's see if he has a little video of this. no, lorem ipsum. But yeah, you could click on a room and it would open another little window that tells you the temperature and if it's occupied or if it's empty. So you could, and it nicely animates when you click on it, and all those things are already built into Tkinter. And I think here he shows how he imported vector graphics from, in this case, from Inkscape. This is the example that comes with Tkinter. And he added those functions to his own architecture. And yeah, so Tkinter is a very nice way to visualize stuff. And you have all the power of Python right next to it. So if you wanted to have some fancy graphs, you could use all the other libraries that Python offers. So in general, if you're thinking about doing something where you need an interface like this, I would recommend you to have a look into Python and Tkinter.
I don't understand in that example what's the accomplishment, what is it do?
The temperature for each room. So you click on a room and it tells you the temperature. And you could say, okay, now I want to switch off the lamp. And you click on the lamp and your physical lamp switches off. Yeah. No. Actually, there is, I think, a firmware that interprets that where you can program in Python and then upload this to your Arduino. In the end, it's going to be in binary, but you can use Python just the same way as we use Java right now in Arduino for creating C code. You can also use C for. You can also use Python for generating C code.
So basically, for electronics, there's only C and Arduino.
If you go to the lowest level, it's all assembler and C, but then there's stuff like Python or Arduino, or I'm sure you can find a way of programming this in Java as well, or in probably a whole bunch of other languages. But Python is kind of would make sense to use Python for that. So if you look, for example, at Sam Kallish's design, where remember the guy that built the sensor for the foot with all the pressure sensors? And this is his Tkinter application to visualize the pressure in the shoe. And I think he also played around with it a little bit just for seeing if you can do more complicated stuff as well. This is a 3D graph that is animated. So yeah, Tkinter has a lot of possibilities. You see the foot. And the nice part is that here's all the code. So if you wanted, you could just take it, change it. That's another nice thing about Python, that there's lots of code already available. You can just reuse for whatever purpose. Okay. Python, Perl, Ruby, JavaScript, Node.js, V8, NPM, ASM, and WebAssembly I don't know. And then all the device interfaces. So this is all the different ways you could talk to it. We're mostly going to talk by the serial port. And yeah, or by USB in some cases, which is in the end also serial. And then there's a lot of other ways of talking to your board. But maybe for the moment we stay with our good old serial. To be honest, I've never seen anybody doing anything but serial. Then data interfaces. It's a bit weird because he puts OpenOffice Calc and Sheets in there. I will have a look at those. So it's like Excel. You could use Excel for programming or for interfacing with your board. PySpread, I guess it's a Python version of a spreadsheet program. And MySQL and MongoDB are databases. They're used a lot in web programming. So if you go to, if you log into Google, where you log in gets compared to is a MySQL database. Then user interfaces. So we talked about TK, tkinter, EX widgets, Python. This is all Python stuff. Then those are, and this is where we get to something very fundamental. So when you look at your Mac screen, like all the things it does, the buttons and the windows and all of these things, is called the window manager. And you could run different window managers. For example, for Linux, you have a whole collection of them. Right now, a very known one is Unity, which is the one that you use on Ubuntu. But there's a whole bunch of others, and each of those, they use a library for generating all those graphics for the frames and windows and whatnot. And one, I guess the most known ones are Qt and GTK. So this is a library for C++ that allows you to draw windows and stuff like this, but on a very deep level. It's, I don't know, yeah. And then the others, I would have to look them up.
Can I ask a question?
Yeah?
In the lecture, you were talking about which widgets and which icon.
Yeah.
And you said that it's which widgets allows you, and those are native book instead of icon. So the both cross-platform.
I guess I'll have to look this up. I'm not sure. I guess the tkinter always looks the same on any platform, and maybe VX widgets takes the libraries from your operating system, so that the Mac window looks like a Mac window, looks like a Windows window. But yeah, sorry, I'm not sure. Graphics X Windows. So this is the this is even one level deeper than your what did I say? Window manager. So this is what your Windows manager is running in, and there's different ones. Then this is all different versions. I think Swing was also a Java something. Yeah, actually, this was called Beans and Swing. Once I programmed something in Java which was using Swing. Yeah, it's a good idea to click a bit through the links from you just for getting a coarse idea what this is. Then Canvas, and I bet he talks about the Canvas element in HTML5. Yeah, so this is when we talk HTML5, it's actually the big new thing is the Canvas element, you know? So as you know, we have all those tags for H1, H2, bold, and cursive. And there's now, in HTML5, there's a new tag which is called Canvas. And the Canvas element allows you to address single pixels on the screen. So you can say pixel 5020 is red, which was not possible before using regular HTML, apart from like drawing a table and going crazy. But yeah, and so this allows or allowed people to program their own frameworks. Like nobody wants to draw every pixel. So you make if you want to draw a line, you make a little library that says, okay, if I want to draw a line from here to there, calculate which pixels have to be on in order to see the line. And there's lots of packages that already have this done. So 3JS is one of them. And so it's a framework on top of the Canvas element that makes it easier for you to program 3D graphics. SVG, there was a point in time where people were expecting SVG to be the Flash killer, because Flash was used because they were transmitting bitmap graphic over a slow internet takes ages. So instead they use vector graphics, just like what we do in Inkscape or in PDFs. And SVG actually, the specification of SVG allows stuff to be animated and to move and all kinds of things. And it would have been easy to replace Flash just by animated SVG, but Microsoft just kept blocking all those features. Not even transparency was supported for SVG. You always get a gray background no matter what you did. And this is why Flash didn't get killed by SVG, but it's still there. Everybody apart from Internet Explorer perfectly supports SVG for doing all kinds of things. So yeah, it's a nice standard. It's open source and has all the nice words associated with it. And you can do very interesting stuff just by animating SVG. You can move each point or move objects. So yeah, this is another interesting thing to look into. Do you have a question? Then yeah, WebGL is one of those how do you say, frameworks for programming 3D graphics in web applications. And this is the thing that you need if you want to run like a 3GS application. If your graphics card is not WebGL compatible, it will just say, I don't support WebGL, and so buy a new computer. Then 3GS. OpenGL, I don't know if I have to mention this, but OpenGL is the, how do I put this? Well, you know what drivers are, and OpenGL is basically a driver for your graphics, or it sits between the driver of your graphics card and your application. And it allows you to do stuff like 3D hardware acceleration and things like this. The two big players are DirectX, which is the Microsoft thing, and OpenGL, which is the supposedly open source variant of it. And we're still in this fight. I think OpenGL is winning, but Microsoft still pushes like if you ever installed DirectX, this is what is replacing the OpenGL. Actually, if you're running applications like SolidWorks, you can choose if you want to run it on OpenGL or on DirectX. And mostly it runs better on OpenGL if it's not a Microsoft problem. And then again, RenderMan, Pixie, we talked about this, no? You still remember what RenderMan is? Yeah, RenderMan is a standard for describing 3D scenes. So if you want to model and render a house, you could put it in a certain language that looks a bit like an HTML, and all RenderMan compliant renderers will be able to interpret this information and make a nice rendering from it. And there's a whole bunch of RenderMan compliant renderers. One of them is the in-house renderer from Pixar, which is not publicly available, but there's others like Pixie that are open source, and you can just work on the same style than Pixar does. The tricky part are the shaders, and shaders for RenderMan are, some of them are extremely complicated and would cost a lot of money if you try to buy them. I think I mentioned the red shader. Andy, can you mute me? Or are you saying?
What do you mean?
Can you mute your microphone?
I can't understand you.
Your microphone.
Okay. Should I mute it? Okay.
Yes.
Okay, this is 2 seconds.
Okay. Yeah. So yeah, RenderMan, Pixie, CG Kit, I don't know. And to be honest, up till Unity, I have no idea what all of them are. This is lots of new stuff since last year. Yeah, Unity is, let's say, it's one of the most popular game engines for people like us that don't have the money for buying something like Unreal Engine or Far Cry engine. I think Unreal and Far Cry are probably the most advanced engines around. Actually, you can use the Unreal Engine, and Unreal 3 is completely open source. The Unreal 4, you can get a demo version for free, and actually for Far Cry, or the Far, is it called Far Cry engine? Yeah, yeah. But it's not Far. It's the Cry engine. No, it uses the Cry engine, which is, like, in my opinion, the most advanced one right now. And you can if you go to if you search for developers Cry engine, you can download it for free. And once you make money with it, you have to pay for it. But it's amazing. Like, maybe remind me in the end, and I can show you some videos that will blow your mind. Like, nowadays, this is real-time 3D graphics. This is not a render.
Everyone was the person.
Yeah. Okay, and remind me in the end, I will show you some videos. Especially for the architects, this is, I don't understand, like, how can you be an unemployed architect when there's Cry engine for free, and you could just make product presentations that your clients will just, like, won't believe it. For this engine? Yeah. Yeah, maybe we can have an Unreal Unity day or something. So, where was I? OpenGL. Yeah, Unity has a similar approach. I think the limitation of Unity is that it's limited to one processor. So if you have a multi-processor setup, it will only use one processor. It used to be a screen resolution limitation, but now I think it's only limited by the amount of processors you can have. Apart from this, it's free. But I guess if you want to go commercial, you will also have to pay. But it's easily accessible, which is why many makers are playing with the Unity engine. For example, last year, Tai Chi was programming. He had two little dummies, or how do you say, dolls. And he would have Hall sensors in all the joints, so he could measure how one of them is deforming. And it would send data by wireless to the computer. It would animate a 3D model in Unity. So whenever you went like this, you would see in his little 3D model in Unity moving as well. And it would transmit this over internet to another little robot puppet that would receive the data it moved. So this is kind of the, yeah, this was really cool. He was 24 when he came here. Yeah, and then CUDA. CUDA is, like, at some point people realized, hey, we're making graphics cards that process a lot of pixels in parallel. So your normal CPU is optimized for taking instructions that come serial and process them as fast as possible. But in graphics, you want to see all pixels at once, so you split it up. Instead of doing a serial process, you do it in parallel. So you can, and since our graphics demand gets a lot higher, they do lots of calculations on the way. So if you have a 3D model and has the ambient background color and a brilliant color for the spots where it hits the light directly, something has to calculate if this pixel is a bright pixel or a dark pixel, which depends on the angle that it has to the light source. And if it's reflective, it has to figure out what it is reflecting. And so there's a lot of stuff going on for each pixel, and all of this in parallel. So graphics cards are great for parallel processing. And so people suddenly started to make gigaflop computers just with their graphics card. And NVIDIA realized, hey, this is a business. It would be nice if it was a bit easier to access all of those, all of this computing power, and they started CUDA. And CUDA is kind of a common interface for graphics cards, to mostly NVIDIA graphics cards, to use the power of your CPU for doing, of your GPU for doing calculations. It's mostly used for calculation. So let's say you take a bag of nails and throw it up in the air, and you wanna calculate how each of them lands on the ground. This is a rigid body particle simulation, and if you did this on your CPU, it would take ages and run super slow. But if you do it on your GPU, it's a lot faster, and it's better for calculating stuff like this. So CUDA is big with the gamers, because if you want to play a cool video game where they have lots of rigid body simulations, or even soft bodies and fluid simulations and all of this, this is what you want CUDA for. And OpenCL is kind of, I keep forgetting what OpenCL stands for. Yeah, I think OpenCL is kind of the CUDA alternative in open source. Then SDL, Pygame, Open Frameworks. This is where I would like you to pay attention again. So Open Frameworks is, I would say, the state of the art in artistic interactive programming. So whoever you talk to that is earning his money as an artist doing programming, they know and love Open Frameworks. It's also cross-platform. It's not a program, it's rather a library, and it's a library for programming in C++. Computer is programmed in, so you can do anything with it. There's no limitations. Anything that you can do with a computer, you can do it in Open Frameworks if you integrate the right libraries. In short, Open Frameworks is the compiled version of processing. So it's as easy as, it's a bit more difficult in processing because you're suddenly sitting not in the nice little processing application, but you're using Microsoft Visual Studio or code blocks or another few editors, but they're all big, massive programming environments that are used for programming stuff like Mozilla Firefox. So you have to deal with this amount of information that is presented to you. But actually, once you know where to put your code and how to compile it, it's not that big of a deal. And you have to integrate all the example libraries. You have to configure all your paths so that all the stuff is really running. It's great for integrating stuff like there's a image library from Intel that is now open source. It's maintained by the same people than the ROS robotic operating system, OpenCV. And OpenCV is kind of the standard for doing image recognition and working with video streams. And it integrates very nicely into Open Frameworks. So if you want to do crazy multimedia interactive stuff, then this is your team, Open Frameworks with OpenCV. And let's look at a few videos in the end from Open Frameworks as well. Open Frameworks and CryEngine. And good news, like I saved you all the boring part of configuring Open Frameworks by compiling this little Fabian, the Linux on a stick. And this one already has Open Frameworks installed, configured, and running. All the examples compiled, so you could just like put the stick in your computer, compile an example, and ta-da, you save yourself a day of downloading and configuring and stuff. I also have Pure Data on there. It also has Super Collider, which is another way of making sounds. So in contrary to Pure Data, Super Collider is really focused only on sound. So it doesn't do video or anything like that, but it's very good at doing sound. Yeah, so the Fabian is great because it kickstarts you in all of those. Yeah, then math, and this is where yeah, Neil has a lot to say because this is kind of his business. Most of the academic people, they exclusively use open open source software for doing their stuff. If it's not open source, then it's MATLAB. MATLAB and Simulink, because there's no real replacement for Simulink. This is why many people still stick with MATLAB. I think Simulink is one of the main reasons. Also, but actually, Sage can open MATLAB files, so that's not really the reason why you wouldn't use Sage. And Sage and Octave and there's another one. There's like several, there's a department of programs that we could call math programs. Mathematica, MATLAB, MATCAT, Maple, and MATLAB. It's like the 5 big ones. Each of them has a little specialization. For example, Maple is very good in doing symbolic operations where you don't calculate it, but with letters. MATLAB has the big Simulink advantage. MATCAT is great because you can just write formula as if you would write them by hand, but they're interactive, so you can use it as if it was a LaTeX sheet with nicely formatted formula. And Mathematica. Mathematica is the one that from Wolfram Alpha, very interesting person. If you're interested, look for Wolfram Alpha inventor and then search for a video with a talk of this guy. He's amazing. So he invented Mathematica and another few cool things. And then Sage. I'm always mixing up Sage and Octave. I think Sage is the one that is basically just a collection of all those Python scripts that help you to do math. And yeah, this is if you have something to do with when might we need this? Yeah, to be honest, right now I can't come up with any easy example where we would use MATLAB or Mathematica. But yeah, I guess you can picture what you need a math program for, no? Then there's R, and yeah, R is kind of the same family, but it's more focused on statistics. And it's also amazing because it's another open source program that became industry standard. So if you look at all the research in statistics, or in people that work with statistics, it's all R. Okay, I think that's it. And we covered Firefly and processing in 3JS, HTML5, Open Frameworks, Big Data, Python Tkinter, Unity. If you want to have a look, Unity also has a plugin for your browser, so you could run your Unity application in the browser if you have the plugin installed. And this is amazing. This is kind of like Grasshopper in your browser.
Hello and welcome to this introduction to MetaMachine. In a sense, MetaMachine is about the future of manufacturing.
It's a guy from New Zealand that was more into visualization of stuff. So he developed this visual programming language for doing stuff that also looks good on your monitor. And thanks to WebGL and all of this, we can actually do stuff that looks really good.
Enjoyed online.
And you can you can get a nice preview
this
of the
model
model.
is parametric, meaning that we can
Maybe I leave this running for a
the
second.
table, change the leg angles, quite a bit more. So let's have a look at tabletop here. Let's turn this into proper, say, conference room table. MetaMachine can give you a preview of how much space it's going to take on a standard sheet of material.
So it knows the sheet size. If it's too big, it moves it to the next sheet.
Leg placement. 3 layers, let's add a 4th one.
It knows that the legs should point to the middle, so even if you move the legs around, they still
always
behave in the right way.
The usability for non-technical users. And so whatever we do here, say for example, we change the height of the table note that the price changes dynamically.
Can automatically calculate the price.
Because we calculate the foot length of the outlines and the material usage dynamically.
No, it's Grasshopper.
Dynamically. So once we're happy with this, we can.
There's only one window of maybe 5 windows that this guy is using.
Good question.
Submit the order. What that's going to do is send an email to the manufacturer with a link to this very configuration.
This is an application for ordering from OpenDesk.
So here's the email. We can open it.
Ah, yeah, it says.
It's showing.
Yeah. So maybe for giving you a bit more idea of what this actually looks like. Yeah. So this is the interface. So you cable along like in Grasshopper. Actually, it's very beautifully made. If you go to the entries, it's the in or outputs. It like feathers open and shows you all the possibilities. And you click on one and it feathers closed. It's very similar to Grasshopper, but a bit more beautiful. And you can put layers into.
For example,
it's free, yeah.
We have a price marker here that reads something from the table, and the tables are hidden here on the side. So we're writing values to the table and then reading them out here, calculating the price based on those table values. And a classic parametric example, classic parametric setup, the C shell. So we start with a circle and move that circle a little bit to the left. And copy that 2 times. Open it around over here. Copies. Copy scale. Every copy down a little bit compared to the previous one. Note that there are these curves which we can spin into a.
Yeah, so it's just like Grasshopper, but it runs in the browser.
So how can we make this more
and
interesting for
yeah, no need for paying anything to anybody. You can completely legally make something Grasshopper style.
How do you buy?
Huh?
How do you like play it?
How do you?
Play it.
Just like Grasshopper.
So you sort of.
Ah, yeah, if you want to use it, like let's see if I have it installed. I think I do. Hey, where is it?
In the URL type FabAcademy2016.com/app.
Ah, no. Okay, no, on this operating system I don't have the plugin installed. But once you install the plugin, it will just start right out of your browser. Yeah, the Chromium is just another version of Chrome. Okay. Ciao. And back to this. Oh yeah, I wanted to show you. Okay, just one quick thing. If you look for processing tree, that's what we're going to do tomorrow. We're going to use this example from Daniel Schiffman, and it animates a fractal tree by your X mouse position. And our aim for tomorrow is going to be to replace the X mouse position by any of your input devices. So let's say you made the distance sensor, and you could like open and close this tree by moving your hand over your sensor. So this is the thing for tomorrow. So it's very satisfying because even if you don't program all of this yourself, you just take some code that already exists and just add on what you want to do. And we did lots of cool stuff last year. You should have a look. If you already have an idea for what your application for your final project should look like, then you could, for example, look for processing examples that kind of look different, similar. So we could just hack in there and use it for what we want. Yeah, so I guess tonight you should just like click on all those links just for getting a coarse picture of what's going on, and look for have a look at those that I consider more interesting. Firefly, this is I guess for the ones that are already like the Grasshopper gurus. It's not easy. I think somebody tried. There is a module for Arduino that you can just like drop into there, and it runs out of the box. But since our little guy is not on Arduino, it's a bit more complicated. It is possible. My colleague in Lisbon, he did it. Maybe should I show you? Okay, so here we have it. Rhino is the base software, then plugin is Grasshopper, and plugin to the plugin is Firefly. Like, yeah, so much on that. And Firefly is using a firmware that lives on your Arduino that is called Fermata. And actually, Fermata exists for many different applications. So, for example, if you wanted, you could have a Fermata for processing, so that you can basically send your instructions from processing directly to your Arduino. It is kind of limited, and there's not, you can't do everything with it. But if you just want to read or write to ports in a not super fast, but in like normal times, then you can do all of this directly with Fermata. There's a Fermata for Pure Data as well. I'm sure there's a Fermata for open frameworks. So this makes your life easier, and I asked Neil if we're actually allowed to use it, because it's so easy that it should be illegal. But yes, we are allowed. And
so by the Fermata, we can upload the Arduino card.
You download Fermata for Firefly, you upload it to your Arduino, then you open Firefly, and you don't ever touch your Arduino again.
But if I want to use this, the Arduino should stay connected to Firefly, but supercomputer, I think it should stay open.
Yeah. Like if you don't have Firefly running on your computer, there's no Firefly. And yeah, so I guess you know this the way of cabling along in Grasshopper. And here there's a Uno read command. So hooking up an Arduino Uno with a button is quite easy. But once you leave the Arduino Uno environment, it gets more complicated. So here you can see, pushes a button that turns on a LED, it switches from 0 to 1. But his aim was to control it with his little board. I think it was a light sensor. And he managed after, like, actually the inventor of Firefly is one of the how to make absolvents. So after, inspired by FabAcademy, he developed Firefly. Well, I don't, kind of. But he's responsive, and he answered to Luis's emails asking, like, oh, how can I do this with my Tiny? Because he knows, because he did FabAcademy. And yeah, so it's actually quite nice. He did an application which measures the light that comes into a room and dependingly opens or closes the window blinds. So you can see his room in the background with the light sensor. And now that it gets light, so it's a time lapse over the whole day. Now that it gets dark, it opens the window blinds. I think he has some of his code in here, but Yeah, don't picture it as too easy. It's not as easy as connecting the Arduino Uno. Okay, processing, we're going to have a little, like if you want to do it the really easy way, then you just attend my class tomorrow and you're finished. But
I wanted to do another Node.js, really famous at the moment, is also a Node. It's on every Raspberry Pi pre-installed, and you can also install it on a computer, and you can like program with nodes.
Yeah, it's not super easy, but it's very interesting. Because suddenly you can connect, create a web application basically.
Yeah, the cool thing is you can just download something and then it runs in 2 minutes, like a Wi-Fi sniffer or something.
Yeah. Yeah, this is why I put the 3JS here. In the end, if you want to use 3JS for communicating with your input or output device, Node.js is what you need for doing this communication. This is like you all understood how Node.js connects between the web page and your hardware, no? No? JavaScript.
And then
basically
not Node.js. I was Node-RED. It's a graphical interface for Node.js.
Node-RED?
Node-RED. Google that. It's really cool. Node-RED. It's from open source from IBM, and yeah, it's for Arduino, Raspberry Pi. We did many things here in our lab with it, and yeah, people that really like it.
Okay, yeah, it looks good. Has a nice interface, and it's based on Node.js, so it's somewhere in this along those lines. And yeah, and 3JS, I would just put it into the same box. 3JS is interesting for you because you could earn a lot of money if you knew how to use it. Full stop. I bet everybody here in the Fab Lab, like right now, you met Isaac, no? The one with the twist-up chair. He found somebody that helps him programming in 3JS an application where you can texture this stool. And so somebody can go into the browser, paint the stool in crazy colors, and it generates the files that he gives to the laser cutter or to the milling machine, so he can mill his custom name or logo or whatever on the chairs. And I bet anything you want to produce, people would be happy if they could customize it and make something fun. Yeah, okay, let me just as a reminder, we want to see videos of CryEngine, open frameworks, and this is running in 3JS. But I also wanted to say something else. So, yeah. Yeah, 3JS, like you can all put it under the title of HTML5. Open frameworks, pure data. Should I show you? No, I showed you my example already. Python tkinter, I don't have anything to show. Unity, you can just look for some examples yourself. And yeah. If somebody's interested into the math programs, I'd be happy to help you. And let's just have a quick video session of. I think now there's CryEngine.
And this is more interactive, but the better is then when there's movement, then he sits there.
Can you mute your microphone again, Andy? Yeah. So this is just a.
It wasn't me. It wasn't me.
Yeah. So free SDK. And this has all the bells and whistles that a modern game engine can possibly have. Real-time memory occlusion, HDRI. Depth of field. This is all real time, it's not rendering. Like if you have you probably need the most powerful computer you can buy right now, then you can get real time rendering like this. No, 2 NVIDIA partners.
Achieved with CryEngine 3.
Okay, should we look? Unity is the same thing, it's just another demo. Sorry? What you need to code? It comes with its own programming interface, basically. You could develop in Blender, and you import the models, and then all the programming is done in the engine itself. It's very... Yeah. And this is the same thing in Unity engine, but should be just for fairness. What if then we have to look at all of them? Like in my opinion, the Cry one is just the craziest one. But of course, Unity is a bit more open. And Blender is completely open. And Blender also has a game engine. So like.
No.
So whenever you hit P in Blender, you're in the game engine. And yeah, let's just look at something just for showing you that this is a Blender game. This is what I did, amongst others, for my interface and application design. I used a Python script that runs in Blender and receives data from my input device. So I can move geometry, or basically you can do whatever you want. It's just animating one parameter of, could be a crazy fractal or just a box. And yeah, so it's not as fully featured as the others, but it's, I think, a reasonably good-looking game engine. If you want to look at the last big open source one, where you can get all the materials, all the animations, everything for free, is called Hello Frankie. Oh, Yo Frankie, sorry. So you're like a little squirrel, one of those that can like also fly, and you an arrow. But yeah, so Blender would also be a nice option, especially since I have the code already. And what was the last one? Open frameworks. This was kind of my introduction to the whole Maker community. So I ended up at an event called Summer Lab. And without knowing, I was suddenly sitting in the, how do you say, the league of the most famous open frameworks users. Let's have a look. Actually, I should comment a little bit because it's so fast. So you saw the one where he's moving his fingers and they're like going crazy ways. This is heavy image manipulation. So you analyze the positions and you, according on the acceleration, you change the length. Then the next one, particle simulations, quite computationally extensive, but with a good graphics card, it takes a lot of stuff. This is kind of what we want to do. This is probably some camera tracking him, so it knows where he is, and it sends data to all those little, probably stepper motors that orient the mirrors in his direction. This is a funny one. You can, it does a face recognition, so it identifies where your eyes are, where your mouth is, where your nose is, and you can swap face with somebody. We won a programming contest where we made the nuclear taco helmet, and our presenter was presenting everything in the Japanese game show style, and he can speak. Actually, should I show you this one as well? Maybe after. So he's talking English with a Japanese accent, and he put himself a Japanese face, and yeah, it was quite fun. This is from the graffiti research project. I don't know if you've seen this, where people have a laser pointer and they project onto a wall, and they can just graffiti tag with a laser pointer. This was the Graffiti Research Lab, and now this is the extension in 3D, because since you're painting, it also knows how time passes, and if you make time another dimension, you see the drawing line in 3 dimensions, and you can print this from, if you look from front, you see the graffiti, but you could also print it as a 3D model. This is a nice project from an Argentinian artist. So he takes a Kinect camera and puts it over sand, and he projects a landscape that depends on the distance value from the Kinect camera. So if it's high up, it's a mountain. If it's low down, it's water. So when you dig a hole in there, it will fill with water, and fish will start to swim around in it. If you make a little mountain, it will like have grass up to the top, and if you make it even higher, then it's rocks, and you can just like carve around in the sand, and it will adapt your real-time generated landscape. Yeah, with image tracking, you could create an interface just by moving sliders on paper. This one, I don't know. This one with the eye tracking was a robot, also quite known project. They made a robot face that would look at you and follow wherever you go, and it would twitch the same way that you would do, which is something that we unconsciously do. When I talk to you and you blink, I will blink as well. And so they simulate this with this robot, and it really gives you some weird feelings when he's looking at you and blinking the same way you do. So it's quite a famous example. Developing 3D scanners and stuff is also optimal. This one is also nice. So the kids, they can, if they do certain gestures, they can grow trees, or they become a lion. If they go like this, it's a big lion and a big mouse. And you see this one? Okay, so open framework is kind of the killer application when it comes to stuff like this. At the summer lab, we made something quite crazy, which was the Machina Absurda. It's like a machine that doesn't do anything, but it would have a speaker with lentils, and when there's a sound, the lentils would jump up and down. There would be a camera tracking the movement of the lentils, which would would communicate to a laptop that has like these flags, like for the airplanes. So there's a sign language that you can talk with flags. So this one would give flag signs to another computer across the room that would understand the flag signs and accordingly activate an actor that is sitting on a washing machine that makes it vibrate at resonance frequency, which has a laser that is pointing to the surface, which is then getting reflected to a point on the wall where there's another camera tracking this one that affects a clothesline that is on the 3rd floor, which moves the clothes forcing back, which is then influencing the movement of a motor that sits on the ground that is eccentric, that like wobbles around, and like it's like 50 nodes like this. It's like halfway through, and they turn it on without knowing what's ever going to happen, but produced a lot of graphics and noise and lights and stuff. So, I don't think so. If you want, I can show you the nuclear taco helmet. This is already a bit old, but it's a good example because it does all of this interfacing with hardware and stuff. So it's an event sponsored by a Portuguese telecom company, and it's a 48-hour programming contest, and we won the first prize. And shitloads of good stuff. Hey, the problem is you only have 90 seconds for presenting your project. I read the model. I just for explaining, so since it's quite a nerdy thing, people get badges for all kinds of things. So if you're the first one on the first day, you get the early bird badge. And there's a taco eating contest, and so who eats a super spicy taco the fastest gets the nuclear taco badge. And since we knew this already, for the next year, we made a helmet to properly identify the winner. So it would measure your humidity when you sweat a lot, or you had these 2 cups in the flow sensor, so if you drink a lot, or your temperature rises, it would like increase an indicator on your helmet that would go from spicy to nuclear spicy. And more lights would go up, so the more spicy, the more red you would glow. And this is the 4 participants competing against each other. It also has like a little time-lapse camera in front. Yeah, I think we won one laptop, this one. This is why I have a Mac, because I won it. 3 telephones, 3 iPad Touch, iPhone Touch, one of those eye things, and a huge screen. This all went to the hackerspace, and yeah. And this is all, the whole, everything you see on the screen is running in open frameworks. So you can mix video with 3D graphics and real streaming audio and video. Me and 3 friends. In this case, it was him doing Felipe doing all the open framework stuff. Okay, and yeah, so we saw some open frameworks things, and I guess 3JS. I would recommend you to look at Mr. Loop. And there you have a big collection of all kinds of things. I kind of feel like I forgot something, but I think that's more or less it. Any questions or comments?
You have only participated this task this week.
Yeah. Tomorrow at 3.
So,
Doesn't do anything. Oh no, it rotates faster. Oh yeah, no, this is editing text files. Yeah, I would really like to see somebody trying this with a with News way of having the data directly in the browser. Then also great would be something with 3JS, and then of course the data open frameworks processing. We think we're a bit behind with the networking and communications. I was expecting lots of projects using the ESP8262888266. Nobody so far. This is quite interesting. Like, you should reconsider if you want to. Maybe you did your node board already and you want to try something else. I think this is interesting. Yeah. It's not easy, but I think it's, yeah, if you don't try, then I will try. I have zero experience with this, but for example, the hackerspace of Barcelona, the MAID, they had, last weekend, they had another event with kids where they built, you can use it's this big board, we just had them here. It's a tiny little Wi-Fi board, and in bulk you buy it for $2 from China. And they used it just as a distance sensor. So if you have one that is a sender and a receiver, you can identify how far you are away from the other one. They made games with the kids in the forest. They hide some of those, and together with a bunch of chocolate, and the kids have to go and find them. And so they made their own little circuit where there's an LED blinking, and the closer you get, the faster the LED blinks. And yeah, you can imagine that the kids had a lot of fun running around in Valdaura searching for the ESP8266. But it's also, I think in theory you could stream audio over this and make a portable Wi-Fi radio. Or this is not what I would recommend you, but I think it's a good idea to at least like send a hello world to it just for giving.
I think that once the final project is done, then maybe that's something.
Yeah.
And now you can hold
Can we do the assignment as part of the final project, or sometimes the opposite? Can we do the final project as the assignment?
Well, since your final project has, let's put it like this: anything you produce for your final project, you can use it as an assignment. So let's say you make something big for your final project, then you could declare this as you make something big. Or let's say you program, your final project has a Wi-Fi connection, then you could stamp this as your Wi-Fi.
We did it step back.
Yeah. Anything else for that?
Did you show the
CryEngine? Yeah, you had a short look. Yeah. Yeah, I think it's. Why is it talking French to me now?
How much difficult was 10 years ago, 5 years ago.
Yeah, it's not this one. I think there is a. You can just click here, get CryEngine. But there are forums for. Or actually, let's look at it. I think it's called Dev. CryEngine Dev or something like this. No.
I think it's one.
Yeah, here you can browse through a whole lot of demos and I don't know, this is going to be good. But it's interesting because they explain you all the modeling process, give you screenshots from the work in progress, and hopefully a video. No. Yeah, never mind. Yeah, that's it, no?
Thank you for it.
It's hard because there's maybe a thousand it's very powerful, and you can do stuff like this regularly. They are really like, I was like, I can only know one CC company, then negations, but all something like that, and so
Might still have it open? No. So this one is, the first one is metal machine. Like this. Here, I just showed this video. So here they're, for example, changing the chair.
Material stock that's currently available, not exactly developed.
I use it for models. Yeah.
Tweak the design.
For every machine. No, right now we're mostly using it for the small building machines and for the vinyl cutting. And so this one, so
solutions.
and another
page that you might like is this one. It's nervous.com. If you search for nervous system, you will find it. And they have in the shop. Maybe I have to search for nervous system. So with this one, you can let's choose a product. Let's say we want a ring, and so I can interact with the 3D model. And if I click, it will subdivide those cells, and I can just go crazy and change the size, change the cell structure. But it doesn't do anything. Something's also my screen is too small, I guess.
It's like Shapeways.
Yeah, and it actually sends it to Shapeways for printing. And here you can choose your material. So if I say, and here you can change the size. Let's say I want it in metal out of silver. It's $109. And depending on how you change the geometry, the price might increase or decrease. Yeah, they have another few ones. Let's see if I can make it cost more.
I just have an idea that it's better it would be great if Fab Labs, you know the Fab Labs EO website. If Fab Labs would have a simple interface for customers for instant pricing.
Yeah.
And I started the same project in Russia. I call it for market. This is my project. It's in Russian language, but it's easily to understood. Right now, I have instant pricing for laser cutting. I took the part of code from LaserZao, how they measure how many meters.
But LaserZao has their own software?
Yes, LaserZao it's called. We also produce LaserZao locally. It's very actual topic for Russia because we have a lot of say additional costs from government, from customs, and
this would be great. Like this would be very useful for many things. Right now, a team here in FabLab is developing the Fab Shop. There's a place where you can buy stuff made in FabLab.
Yeah, we cannot talk me about that, but is it the same like
I think I
Better Machine or
no. For the moment, it's just an online shop. Nothing.
Can you show me the address?
I think it's like this. No. Or is it? But it's still very new. I thought it was shop, but maybe it's. What else could it be? Yeah.
Maybe store.
But store. Yeah. No. But let me send you an email so we're in contact, and I can send you as soon as I find it. It's like this. The ad?
Okay.
Yeah. The Portuguese keyboard.
And this is my website. You can find me at the GitHub or Facebook. It's like our flow.
Yeah, keep it open. Maybe we come up. Would you mind going for a smoke?
Yeah.
I'll find some more stuff like that.
Connect with web.
Oh, I don't care about that. They said.
Obviously, you have to watch something less I hope it was we no, I like and then the will be sending, come back. Second year, we really bounce. It would be nice for you to, how many times?
But it depends on the material, because there are some materials that have like acid or something that you carry, burns a lot, not burns, but melts a lot. And if you not a lot, we're talking about less than millimeters, you know? But this is what plastic. In that case, you are not going to do so much. So I will consider the line to be like a good book, but still. And then just put one line, that's it. Well, put everything, and then when you have it, everything. No, because you have to put one line, and then. You have also there? Okay, now there. Then you shoot your size of your water style, make it a square, more or less, and then also imagine that here. Ahora los actores
were involved in this project? No, not as far as I know. Let's see, I wanted to show you photo mode. So this is very interesting to see how they do a quote. Whoops. This is the one that you showed me, no? Yeah. So Proto Labs. Then I can also put you the one from. Does it open? Oh, stupid computer. Too many tabs open. That crashed.
You know antimony. What do you think? Is this project? Will this project have a future, or is it
To be honest, right now it's more like an academic thing. It uses a type of geometry that is unique to it. So you can do, especially for physicists, it's interesting because you can do things that you can't do in normal CAD.
Yeah, it's not like OpenSCAD. It's not hard coding like OpenSCAD, but it's I think symbiosis of visual and algorithmic.
Yeah, it's very mathematically beautiful. Okay, I think now my browser crashed. Let's see. Come on.
I can use my browser.
No, it's okay. It's, I just had too many tabs, or I still have too many tabs open.
I'm programming on these frameworks I offer.
Okay.
So this is my favorite. MongoDB, embedded JS, Angular.js, and Node.js.
Okay. This one seems also to be interesting. It's called Node-RED, and it's working together with Node.js plus extras. So
do you have any log or maybe list of these projects where you collected? I'm interested in. Yeah,
not really, no.
I understood that you know a lot of projects, more than me.
Let me see if this one I wanted to show you, Meta Machine. Let's see, this is here. Populars, Meta Machine. I will put your links there as well, so I remember them.
Okay. And you showed me a visual tool for Internet of Things.
Oh yeah, this one, where was it? This one here, no? Node-RED. But this one I haven't tried it. It was just a recommendation from one of my students.
It's called Node-RED, yeah?
Yeah.
Also, you market.
Another thing that is very, like, if you're into programming, and this is something that might be interesting for your lab, you know the Happy Lab in Vienna?
Oh, yeah?
They have a nice system where you can enter 24/7 with a RFID card.
Yeah. I have the same project on GitHub. It's called FabAcademy. You can enter there. It's not well documented as a one, but it's quite universal.
GitHub,
cheap.
FabLab61.
Hey, it's our repository.
FabKey, like this?
Yeah. And I documented a little bit. And I think if your lab wants to control students, and it's for doors, for entering, counting entries, for how to call it? You know, Zone Minder. It's a video surveillance system.
Okay.
And it's also open source. And I use this for control my lab. For example, I can Let's see what happens here. PM.
Yes.
This is my lab.
This looks even messier than ours.
Yeah.
Okay, this is interesting.
This is my student. Michael made a laser cutting now.
Great.
And this is a very good open source project. I can recommend you because I use it for recording video from the cameras.
Yeah, we have a commercial system, but maybe we can change this because we have the hardware and everything already, and maybe we can change the software.
Yeah, I can help you if you have some questions, because I investigated quite hardly.
Okay.
So.
Yeah, unfortunately, I can't really. The ones that are here from FabApps.io, they're not really. Yeah, I think there's nobody here that would be very helpful for you.
And do you know, last I already asked Luciana, but she didn't remember. There is a project which called there was two girls. Maybe I'm sure we should search it on YouTube. I don't remember their website. Okay, I tried to do this one.
Huh?
Do you know this project?
No? It's one of those cameras where you push a button and it shows another image?
It's photo frame. When you press the button, you hear an audio which associated with the picture.
Yeah.
And as I understood, they had another fork when screen is animated. Okay. They used a very cheap screen from mobile phones.
Yeah.
And it's also a project of your lab, but I haven't found the founder of this project. So
Less TVs.
One moment I will find a link.
No.
Now I'm trying to collect the list.
Oh, look, there's last.
No, it's no. Maybe yes. Maybe here. Yeah.
Okay. Who is it? Doesn't say anything.
I tried to contact them, but no one responded.
See if you see some people on there. I think I've seen this girl before.
Looks like this project is dead now.
Okay. Pretty.
But it have a very good PR.
Yeah, that's good.
It's quite strange it's dead. Trying to find Facebook. Name of
Standing on your 2 feet, baby. Tell me what do you mean? Oh, stand up on your 2 feet, baby. That's how it's
I like this song.
you want
this
me
was
to be
this
your
girl,
mother.
Sylvia
But you know I'm too young, too young.
and they did this project with Pablo Barcelona.
Your sister.
I was trying to
Look, they're there. Yeah, I think I've seen them, but I don't know them personally.
You think I'm gonna raise you like a kid, but don't matter the love I feel. It's time to show and prove, make a move, do what you gotta do what you gotta do. So, standing on your two knees, baby, tell me what do you need? Oh, stand up on your 2 feet, baby. That's how it's
Nice.
meant to be. No, 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 no. Standing on your 2 knees, baby.
Okay, yeah, I will run around a little bit.
Okay.
But yeah, feel free to just talk to people, and like it's always interesting just to ask what they're doing.
And we will be there tomorrow.
Yeah, I'm always here.
And what is the time of
From
Academy?
10 to 10.
From 10 to 10. It's, yeah, I mean, not your time, but time of FabAcademy.
Yeah? You mean on the long until July the 8th?
Oh, okay. Yeah. So nice to meet you.
Yeah, pleasure.
See you tomorrow.
Yeah, cool. Yeah, if I find somebody that might be interesting to you to talk to, I will put you in contact.
Sure.
Máscaras así, fotos así un poco de... No, pues no tengo Dios, no tengo caso. Should I bring them more?
No, I will just come here. This is only the and then you decide what you want to see. In this case, we have I want to see everything. You said I want to see traces, here I want to see the color. But you can also have to only show the solar panels. And you have this, you could cut the light. And then you put the solar panels, then put the solar panels here on the light, and put the solar panels, then that's kind of
on the table in some place. No, I didn't.
Maybe here in the corner? Yeah. Yeah, well, the whole thing is great. Almost always right.
Buenas noches.
Hola.
See you tomorrow. Nice to meet you. Bye. And yeah, how do I stop this machine? Here? I got you, bro. You lost power. I got you. Just continue. Yeah, so.
Next one.
Wow.
No.
Yes, and then I also but I see so far. I mean, when you talk
Okay, if you ever want to know, like, this is a typical situation.
Yes.
There should be able to stop this.
And maybe like the basic process.
This person reports but do you make your own voice in this? This is actually a way that we practice. They have a problem of voice to look for what product. I know I want all of this.
Vai no campo, né? Se
Which border? So I don't take the edit, but the edit doesn't affect anything.
I was thinking if we correctly say 0 and it's not the balance of not now. Why because accidentally I broke it. I don't know what everywhere. Everywhere. The other one. Yeah. That's the number two. The one or the two. The one or sometimes. Could be also the next one. The table. Yeah, I meant to.
I don't think it's the game like this.
Yeah, absolutely. Did you do any application?
We're going to test it first.
Very nice, and I copied it.
Of course, if I not say yes, you will do it.
You have a letter good. Let's put it on the set of the.
Actually, I've never done this. No? But exactly like, very similar things, but not exactly like this. This one has a crystal on the resume. This is your resume number.
Yeah.
It's a 20 megahertz resume, right?
Yeah.
I use it.
I live in the station. No. So stop it. And replace it. Yeah. Use it as a stencil.
Because you can see it, but the color was not so high. Guys, see you tomorrow again. Good night.
And now what are we going to do? And now, what are you going to do?
FabAcademy. This.
What are you FabAcademy?
It's not working.
The programmer.
Yeah, yeah.
It's not really a solution.
What? No,
Trying to be positive.
Why did you do that?
No, we can try a different solving technique without solving that. Once this one is sitting in its place, we're going to put some solvers on top of the line. And this is a lot easier than using the syringe, putting a bit of solver on every spot. We can just spread it crossly over, and we peel off the wire, and then we just put the heat in.
It's all the components, is that?
Yeah. I'll take some photos.
Este por 0.0. Me gusta ese ojo crítico que eres desarrollado eso. Me gusta ese ojo crítico.
So, no. Yeah. I couldn't be sure. I think I'm going to go back. And
Like, for example, the places are the word is to say, but for example, this, I think also, you need to check the component. And so I sort of pick them out of the file stuff. And I'm more excited.
This is the 0.1.
Would you mind? So you have to understand, just a car outside. And this is methanol for anesthetic. Express.
Yes, we didn't find a monitor.
Yes, I want to do that.
Yeah. After the monitor, you see
Windows. Very nice.
Around 1 meter for 1 meter. And I'll also this another 6 for.
Alright, I'm going to run. Okay, I'll see you guys later.
Yeah, I know.
That should be okay. Okay, ready? Document?
Yeah.
You want to put some? Then we.
Why don't you do it here?
I did.
This one.
I thought it was also
This is nice people.
No, I was able to. Okay. Guys, I need 3 people to start.
This is from.
That's why I know it's not gonna work. I know it's not gonna work.
Now we just take a piece of paper and just write the maximum equal layer of everything.
You don't know better now.
Maybe the last part, will be more difficult. How do you know what to do?
Yeah, so it's 1, 2, 3, out, in, so to the left would be out. And this one is
Yes, now.
This is the 5 one. Yeah, 3 one.
Wow.
Have to show the
You're hiding the one that's working?
No.
Okay.
Because we broke all the dots, the zero problem. And the normal ones go faster.
We have to add Yeah, I think so. It's well, right? Solid.
These classes are like 2025.
I don't know. I have to take out the floor. When you have
No, these are
Do you see? Yeah, do you see the problem? Look at the things in the. It's not. It's so small that the glue. Yeah. Let's keep it. Yeah. Of course. We are here.
What did you fix? It's not working. Of course, I'm sure.
No.
No?
This one.
What?
Yeah.
Oh my god! This is the best day of my life.
But it looks nice, but it has some kind of nice error here.
Yes.
Yeah.
Why did you put the wrong Oh my god! Plenty. Wow.
This is because there's kind of in some places. I still don't know what else to do.
Do you need the border, like the
But you have to explain how you fix it. No, you could say, thanks to the rest of the you have to say that you resolved it is wrong.
Okay, so the problem was resolving.
Solving of the I think that doesn't allow to this board.
So the problem is going through this board.
Well, so this also will be here.
This one is getting power. Ah, yeah. Yeah, it's weird.
I store here. Well, just say that you resolve it again, not very well.
But didn't you put the 10 in here this morning? The one that
No, yesterday night there were only 3 left.
A ver, señores, ¿alguno con la de los libros, por favor?
Yes.
Si le faltan unos 5 minutos, ¿no?
Tú sí. Tú sí.
A pesar de una cosa que tenemos que...
No. Ella no. Ella no, él tampoco.
Nadie necesita más 6 minutos.
Él no, es imposible. ¿Cómo se saca un pedal de una bicicleta?
Difícil.
Difícil, no, imposible.
Mejor gracias.
Pedal. Sí. Ya está el tornillo fuera, ahora no sale.
Ya salió la idea.
Yo sí.
This is so much fun. I'm going to stay all night.
Yeah, we're gonna stay here all night.
And now my board is working. Haha.
Your board is working?
Yes.
Yes.
Because I thought they hate it. Like you. Just about that.
No te pasa. 10 p.m. Pico Ferraz, ¿no?
advancing, so it doesn't become something. Thank you so much.
Okay, done. Yes, we don't have all hyperthreads, so we take.
You can ask me correctly. So you do the capacitors to filter the signal or to
make it the supply voltage.
Bye.
Alles ist zero.
That's it tomorrow, could you send me, or if you serve on your laptop?
It's okay,
then
like, say,
send me the file.
Where? Oh.
Yeah,
okay.
But you're saving the.
Yeah, I saved the text.
I see. That's not possible. I didn't think you were going to. What's the? Oh, is this what you're doing? This thing there. You want
You have the second almost?
You make it.
Okay. But I've never tried this first test.
They never teach you.
I think practice like this, really like the family of guys, and then they say it out.
Everyone should solving.
Imagine Rosie would be at the beginning to give you, an API to do, and to
But for example, the super small, like the super small components, can use this solver thing. There's no way to do it. Yes, you don't know how. I saw your reaction.
it actually is the only way to solve it.
It's only with solver way.
There was tiny shifts. But basically it's the same thing.
But it's that. So why is it not bigger? A tiny bit bigger.
Because that's a tiny bit bigger. And the tiny bit heavier. I don't think it actually makes a difference.
Yeah.
Obviously it does, because the data, but the thing is like, people are not using them.
Anyway, that's
like, like it's not like our huge empty boards. The accelerometer background is used in the V's, like the, anything with an orientation, so to speak. So think about the board can be like full, really full. It has to create a kind of chemical reaction. Now I've seen it here. Oh, shit. Wow. That's. Is it like tornado? Yeah. And you're seeing how the others implement the actual response.
well, I thought you were.
It's doubling the volume.
That's it. Sí,
No, amazing.
That's
And can we, for example, do it without the
Yeah, it's just not
but they can solve it.
Okay, so also
you can see.
show me how to solve it.
So